Welcome back. In the previous lecture, we understood how the transformation works. What exactly is a transformation? As a part of this lecture, we'll understand what are actions. Any idea what is action? In transformation, we understood transformations are the instructions to modify or change the data frame. Now, action is the one which instructs the Spark to do the computations. Transformations allow us to build a logical transformation plan. But to trigger the computation, to make the computation happen, we need to have an action. Let us take an example here. We have already created one data frame called device by 2 in our previous lecture. If you use a count, which is an action here, then we are triggering the computations. Let us see that in action. So device by t is there. We say count. Count is an action here. Okay, this is a count. So we have 5 values. Ideally, until we use a count action here, nothing would be happening. So count is an action. Action will trigger the computation. Please remember. Now that we understood what is action and how do we do that, let us try to understand what are the different types of actions. There are 3 types of actions. The first one is actions to view the data in the console. That is what we just did now. When we said device by 2 dot count, so we saw the results on a screen, on a console. That is one of the action. Second one of the action is actions to collect the data into the native objects. Means, let us say you are working with a Spark using a Python programming language. Python also has some native objects. Now, sometimes you have to write some of the results of a Spark into the native objects of the Python. So that is also one type of action. One more type of action would be to write the output to the data sources. What are the data sources? Data sources may be CSV file or JSON files. Why do we really need to write to the data sources? Assuming that in a previous example, our original data frame was my range, which had some 10 records. Now, after applying the modulus 2 on that to see whether out of these 10 numbers, how many of them are even numbers, we went ahead and used the transformation. Dot where number modulus 2 is equal to 0. If I want to know how many things are there in the resultant data frame and I want to write it back to some of the output so that I can use it further, that is where we need this action, where we are using this action to write it to the output data sources. Let us take an example here. Assuming that you are loading the data from a external file into the data frame, and we have first transformation, second transformation, third transformation, and also at the end there is an action. Okay, there is an action. Let us take an example, real life example for this, and try to understand how exactly this works. In this case, assuming that you have a large employee table with some 4 columns: employee ID, employee name, employee department, employee salary. The first transformation what you want to apply is, you want to apply 10% high to all these employees. That is the first transformation. Then after that, you want to filter only the Spark developers from this. After that is done, you want to see the top 5% of the Spark developers and you want to see them. This is what is the series of transformation and one action. If you really see here, in this transformation, there is a large Spark job, and we are specifying a filter at the end of the transformation. Here we are trying to understand Spark developers, top 5%. That is what is the final filter. Prior to that, we have already applied one transformation. Prior to that, we have already applied one transformation. So there is a final filter here. Ideally, what need to happen is, instead of applying all the transformation for all the rows and then filtering from there, ideal way is to only access these 5% and try to apply the transformation. That is the ideal way. So it will save a lot of resources and also time. What happens is, even though we specify the transformation in whatever the way, what Spark does is, Spark will optimize this by pushing the filter down automatically. Even though we may vary the sequence of the transformation according to our knowledge, according to some of the different aspects in the project, Spark will push these filters down automatically, so that amount of records, the number of records on which the Spark has to apply the transformation would come down drastically. One important aspect here is, we have a load is happening. Then the same example, we have transformation 1, 2 and 3. So what essentially happens is, even though you have built these 3 transformation after loading, until you trigger an action, computations are not happening. This whole process where Spark will wait until the very last moment to execute the computation instructions is called as a lazy evaluation. Lazy evaluation is nothing but Spark will wait until the last moment to go ahead and do the computation. This has an immense benefit, because let us take a previous example. If we have to take a previous example here, in case of this, let us say we have some 10,000 records here. In the first transformation, we will be applying the transformation to all the 10,000 records, right? Because we need to apply 10% hike to all the employees, assuming that out of that we have some 1,000 developers. So assuming that we have 5% of it, 5% of 1,000 is around 50, right? Around 50. At the end of the transformation 3, we need only 50 records. If the Spark would have gone ahead and applied the transformation at each stage, it would be unnecessarily wasting the resources, because what the final user needs is only these 50 records. Because of the lazy evaluation, lot of time and resources are saved. I hope you enjoyed the lecture. Thank you.